In the desperate, innovative crucible of World War II, armies dreamed of the impossible. They envisioned a weapon that could be anywhere, delivered behind enemy lines, needing no runway, no specialized crew. A vehicle that could drive off a transport plane and right into battle. What if that vehicle was the humble, ubiquitous Jeep? What if you could make it fly? This is not a work of fiction. This is the story of one of the war's most audacious engineering gambits. A story that begins not in a vast aircraft factory, but on a simple drafting table in Dearborn, Michigan. This is the time Ford Motor Company built a flying Jeep, and how this 1942 design changed everything.
The year is 1942. The United States is now fully immersed in the global war across two oceans. In the steamy jungles of the Pacific and the rugged terrain of North Africa, a critical logistical problem is becoming terrifyingly clear. How do you rapidly supply advanced forces, airborne troops, and partisans operating deep behind enemy lines? How do you get a vehicle to them without a port, without an airfield? The answer, envisioned by the U.S. Army Air Forces, was as straightforward as it was fantastical. An airborne Jeep. A flying vehicle that could carry men and supplies, land virtually anywhere, and then serve as a ground vehicle. And the company they turned to was not a traditional aircraft manufacturer. It was the industrial behemoth, already churning out thousands of vehicles for the war effort. Ford. To understand the scale of this challenge, we must first meet the main characters. On one side, the U.S. Army Air Forces Materiel Command, led by visionary officers who saw the future of warfare as vertical, mobile, and unpredictable. Their dream was a roadable aircraft or a flying Jeep, a machine with the soul of a truck and the wings of a plane. On the other side, the industrial titan, Ford Motor Company. Under the legendary Henry Ford and his son Edsel, Ford's Willow Run plant was becoming the arsenal of democracy, famed for its B-24 Liberator bombers rolling off the line at a staggering rate. But this project was different. This was to be built from scratch. The principal architect was an unassuming yet brilliant Polish-born designer named Johnny K. Tylechuk. A senior designer at Ford's engineering department, Tylechuk was given a seemingly contradictory set of requirements. The vehicle had to be lightweight, under 1,300 pounds empty. It had to carry a payload equal to its own weight. It had to be powered by a standard, reliable automotive engine. It had to be sturdy enough for rough terrain, yet sleek enough to achieve flight. And most critically, it had to be simple. Simple enough for a soldier with basic mechanical and piloting training to operate. This wasn't a machine for ace pilots. It was meant for the everyday GI.
The strategic situation demanded such innovation. Airborne operations, like those envisioned for the impending invasion of Europe, were hamstrung by a lack of mobile firepower and transport once on the ground. Paratroopers could only carry what was on their backs.
Gliders could deliver heavier loads, but they were one-way tickets, vulnerable, unpowered, and impossible to retrieve. A flying Jeep promised to revolutionize this. It could airlift wounded, ferry commanders, conduct reconnaissance, and shift key supplies across a battlefield devoid of roads or runways. It was the ultimate tactical wildcard. And by mid-1942, with the war hanging in the balance, the Army wanted a prototype. Fast.
Ford's engineers, masters of mass production and automotive design, now had to think like aeronautical engineers. The clock was ticking. In workshops usually dedicated to transmissions and axles, teams began modeling strange hybrid designs. They weren't just building a plane, they were building a transformer. The central challenge was the wing. A fixed wing made the vehicle too wide for roads. A complex detachable wing assembly defeated the purpose of rapid conversion. The solution Tooltrack's team settled on was both ingenious and incredibly risky. They would use a single, central rotor, not like a helicopter, but a giant 24-foot diameter rotor mounted on a mast above the vehicle, an autogyro.
In flight, it would act as an unpowered auto-rotating wing. Forward thrust would be provided by a conventional rear-mounted propeller driven by the vehicle's engine. For the ground, the entire rotor mast could be folded back, stowing the massive blades along the length of the vehicle. The chassis was a simple, lightweight, tubular steel frame. The engine? A standard 4-cylinder, 40-horsepower Ford Pinto engine, the same reliable workhorse found in civilian cars and military generators. By September 1942, the first full-scale mock-up was ready. Designated the Ford Flyable Automobile, or the Model 11107, it looked like nothing else on Earth. It resembled a skeletal Jeep with a giant exposed rotor perched precariously on top. To Army observers, it was either a work of genius or sheer madness. But it met the brief. It was small, light, and theoretically roadworthy. The Army was intrigued enough to grant an official contract for a single, flyable prototype. The project, shrouded in secrecy, was given the official name, the XF247. Now the real pressure began. Ford's engineers, while brilliant, were navigating uncharted territory. Every component had to be stress-tested, not just for the potholes of a battlefield track, but for the violent stresses of flight. The steering system had to work both for tires on mud and for a rudder in the air. The brakes had to halt a rolling vehicle, but also possibly control a landing roll. By early 1943, in a secluded hangar at Ford's test facility, the strange machine began to take its final form. It was painted in olive drab, a stark reminder of its intended purpose. The tension wasn't just technical, it was strategic. Reports from the front lines emphasized the urgent need for flexible transport. The invasion of Sicily in July 1943 highlighted the chaos of airborne landings. Had a vehicle like the Flying Jeep been available, it could have rapidly consolidated scattered paratrooper units. This real-world need was a constant presence in the Dearborn workshops. Every day of delay was a day this potential asset wasn't in the field. The team worked around the clock, the ghost of future battles haunting their drafting tables and welding bays. In the spring of 1943, the Ford XF247, the Flying Jeep, was rolled out for its first ground tests. Without its rotor engaged, it was to prove its mettle as a simple vehicle. And almost immediately, the cracks in the dream began to show. The lightweight frame, perfect for flight, was jarringly flexible on the ground. The vehicle was underpowered. The 40-horsepower engine, sufficient for a small plane in the air, struggled to move the 1,300-pound Jeep at anything beyond a crawl on rough terrain. It was slower than a standard Jeep, less robust, and carried a smaller payload. The very compromises that made it flyable were crippling it as a ground vehicle. But the true crisis awaited its maiden flight. The date was set for a clear morning in June 1943. A skilled test pilot from the Army, familiar with unconventional aircraft, was at the controls. The rotor was unfolded and locked into place. The engine coughed to life, the rear propeller becoming a blur. The theory was simple. The vehicle would accelerate down the runway. The forward thrust would spin up the unpowered rotor via aerodynamic forces, and once enough lift was generated, it would take off. It was a process akin to a child running with a pinwheel. As the XF247 began its takeoff roll, A wave of anxiety gripped the Ford engineers and Army observers.
The sound was wrong. Not the powerful roar of a fighter plane, but the strained, buzzing whine of a small engine pushed far beyond its intended design. The vehicle bounced uncomfortably on its light suspension. It gathered speed, but slowly, so slowly. The rotor began to turn, lazily at first, then faster. It was working. The nose lifted.
For a few fleeting, glorious seconds, the Ford flying Jeep was airborne.
And then, the reality of physics intervened. The underpowered engine could not maintain both adequate forward airspeed and climb rate. The vehicle was dangerously unstable. The linkage between the steering wheel and the aerial controls was imprecise, leading to a sluggish and terrifying delayed response. The pilot fought the controls, his knuckles white. He managed a circuit of the airfield at an altitude no greater than 50 feet. A flight characterized not by grace, but by a desperate struggle to maintain control. The landing was a hard, jarring affair that nearly collapsed the lightweight landing gear. The crisis was now undeniable. The flying Jeep could fly, but barely, and at a tremendous risk.
Its performance envelope was terrifyingly narrow. It couldn't handle crosswinds. It couldn't climb over obstacles. Its range was negligible. In a combat zone, with small arms fire filling the air, it would be a sitting duck. Slow, low-flying, and utterly vulnerable.
The dream of a soldier pilot hopping over enemy lines dissolved in the face of these brutal facts. The vehicle was a masterclass in compromise, and in compromising, it had become master of neither domain. It was not a good Jeep, and it was a profoundly dangerous aircraft. Worse news came from the competition. Another company, Stout Engineering, had also received a contract for a flying Jeep. Their design, the Model 98, was different, a small, proper airplane with detachable wings. While it had its own problems, it demonstrated that perhaps the autogyro concept was a dead end. The Army's initial excitement turned to sober reassessment. Funds and materials were desperately needed for proven, mass-producible weapons, more tanks, more bombers, more conventional Jeeps. The flying Jeep, for all its visionary appeal, began to look like a fantastical diversion. As the XF247 sat grounded, its future in doubt, the true legacy of Ford's flying Jeep began to reveal itself, not in the vehicle itself, but in the ideas it forced into existence. The turning point was not a successful flight, but a fundamental shift in military and engineering thinking that this bizarre prototype catalyzed. First, it proved the audacious concept of vertical envelopment was valid, even if this machine wasn't the solution. The Army's desire for a vehicle that could ignore traditional logistics was now a formal, funded requirement, not just a pipe dream. This thinking directly fueled the post-war development of rotary wing aircraft. Engineers and officers who witnessed the XF247's struggles asked a simple question: what if the rotor was powered? What if you didn't need a runway at all? The flying Jeep was a stepping stone, however shaky, toward the helicopter as we know it. Second, and perhaps more immediately impactful, was the innovation in materials and design philosophy. Ford's engineers, in their quest for lightness, pioneered the use of lightweight, tubular frames and aluminum alloys in vehicle design. The relentless focus on weight saving and structural efficiency for the XF247 provided a treasure trove of data. These lessons flowed directly back into Ford's core military production. The techniques developed to stress test the hybrid airframe-ground frame found use in improving the durability of standard trucks and armored cars.
The true change-everything moment came in the form of a derivative idea. If a flying jeep was too complex, what about a gliding jeep? The concept of airdropping a vehicle intact emerged as a more viable, if still risky, alternative. This thinking led to experiments with large cargo gliders, like the massive CG-13A, which could carry a standard jeep and a small squad inside it. While not as elegant as a flying jeep, it was practical, deployable, and used existing, reliable technology. The failure of the XF-247 closed one door but forcefully kicked open another, redirecting resources toward air-droppable cargo, which included jeeps, howitzers, and bulldozers.
Furthermore, the Flying Jeep project acted as a catalyst for interdisciplinary collaboration. It broke down the walls between automotive and aeronautical engineering. Men who had only thought in terms of torque and horsepower were now calculating lift and drag coefficients. This cross-pollination of expertise would prove invaluable in the post-war aerospace and automotive boom, leading to advances in aerodynamics for cars and manufacturing techniques for planes. The Ford Flying Jeep's heroism was not in battlefield valor, but in the sheer intellectual courage to attempt the synthesis of two incompatible technologies. It was a lesson learned the hard way. The vehicle itself was a failure, but the process of building it, testing it, and understanding its flaws was an invaluable success. It changed the trajectory of military logistics by proving what was not possible, thereby clearly defining the path to what was.
The end for the Ford XF-247 Flying Jeep was quiet and unceremonious. After only a handful of fraught test flights, the Army officially terminated the project in late 1943. The single, lonely prototype was reportedly scrapped, its unique parts melted down for the war effort,
leaving behind only photographs and engineering reports.
No soldiers ever rode it into battle. No medals were awarded for its design. It faded into the footnotes of aviation history, a curious what if. The broader airborne G program met a similar fate. The competing Stout design also failed to impress. The Army, facing the immense logistical demands of the D-Day invasion and the push across Europe, could no longer justify resources on such speculative, high-risk projects. The dream of a single vehicle conquering both land and air were shelved.
Yet, to dismiss this story as a mere failure is to miss its profound significance. The legacy of the 1942 Ford's design is etched into the DNA of modern military mobility. It directly inspired the post-war development of light observation helicopters, like the iconic Bell 47, which fulfilled the Flying Jeep's reconnaissance and liaison role with perfection.
The concept of vertical takeoff and landing, VTOL, for frontline units, realized in machines like the Bell UH-1 Huey and the Boeing CH-47 Chinook, owes a conceptual debt to that strange autogyro in Dearborn.
The human cost here was not measured in casualties, but in the diversion of brilliant minds and precious resources during total war. Yet the return on that investment was a clearer understanding of the possible. It demonstrated the U.S. military-industrial complex's willingness to explore the farthest edges of innovation, to embrace wild ideas in the pursuit of advantage. This culture of sanctioned experimentation is what yielded other war-winning technologies, from the proximity fuse to the atomic bomb.
The Ford Flying Jeep stands as a monument to pragmatic ambition. It changed everything by defining the limits, by serving as a necessary failure that guided future successes. It expanded the imagination of what military vehicles could be, and in its short, hesitant flights, pointed the way to the skies above future battlefields. The Ford Flying Jeep never saw combat, but its story is a vital chapter in the relentless innovation of World War II. It was a dream made of steel, rubber, and audacity that ultimately couldn't leave the ground, yet it lifted military thinking to a new height. This was just one of countless untold stories from the Second World War. Subscribe to the War Archives as we continue to bring these forgotten chapters of history back to life.